Welcome. In this video, we're going to discuss cost measurement systems, the topic that we'll be talking about in the next couple of chapters. Cost measurement systems are determined by the production technology, which is determined by the product flow. The two extremes are a job shop, which utilizes a job costing system, which we'll discuss in Chapter 4. And the other extreme is a flow shop, which utilizes process costing, which we will discuss in Chapter 5. This diagram illustrates these two types of product flow. On the top we have a flow shop. Note that the production flow is sequential. Each box with a letter represents a cost center. So for a flow shop, the product will flow through cost center A, then through cost center B, then through cost center C. Contrast that to a job shop down below. What that attempts to illustrate is the fact that we can have different products which have different flows through the job shop. A second defining characteristic of a flow shop as opposed to a job shop is that in a flow shop, our products are very similar, and the demand or the resource consumption related to each product is very similar. In a job shop, the products can be very different. And that's a result of the fact that you have multiple products flowing through your job shop in a variety of order. Flow shops are infinitely easier to manage than job shops. For example, in a flow shop, your bottleneck will be stationary. However, in a job shop, that bottleneck will tend to float around between the different cost centers depending on what is happening. Irrespective of what type of formal cost accounting system we're going to use, a job order costing or process costing or operation costing, that cost system will be comprised of a couple key elements. And again, an easy way to understand this is to think about what we're working with, how we're working with it, and why we're working with it. The answer to the what question are the resources that are being consumed in order to manufacture the product. How do we go about operating our cost measurement system or our internal management accounting system? Well, we use concepts such as cost objects, we have procedures for tracking direct costs, we have methods for allocating indirect costs, so forth and so on. The things that we will investigate here in chapters 4 and 5. And finally, why do we do this? There's a number of different reasons. In order to determine product profitability, we obviously need to know what the cost of the different products are. In order to determine process improvements, we need to identify the cost of incremental steps. If we were going to do customer profitability, likewise, we would need to have accurate costing. And then, as we mentioned in the last chapter, we have our cost drivers. So this process here allows us to identify our key cost drivers, which is how we actually manage cost, by managing those cost drivers. One point to keep in mind is that most cost measurement systems capture data on resources purchased, in other words, the supply of the resource, whereas what managers really need to know are how resources are used, in other words, the demand for those resources to meet their strategic objectives. Last chapter, we introduced the idea of different costs for different purposes, the idea of throughput costing, direct costing, variable costing, absorption costing, value chain costing. Unless stated otherwise, we're always going to assume that we're working with absorption costing. Absorption costing means that the manufacturing or the cost from the manufacturing business process and only from the manufacturing business process will be assigned to the different products that are manufactured. This diagram illustrates how that happens in job order costing as opposed to process costing. So we have the resources that are purchased, that's what's in brown. We have our different functional areas, that would be what's represented by a value chain. We have our resources consumed, we're specifically talking about manufacturing resources, that's what's light blue. In a job order costing system, because our products are all different and they're readily identifiable, we work with job orders. So we will assign manufacturing costs to job orders. That contrasts to process costing, where we have a basically non-differentiable product. So a good example to illustrate a job shop would be a furniture manufacturing shop where you make various types of furniture. You make bookcases, you make desks, you make tables, so forth and so on. Those products are all readily identifiable and can be associated with a particular job order. Contrast that to a situation where you're manufacturing chemicals or paint or something like that, where the product is non-differential. You cannot differentiate the product. In a job shop, I can walk out on the job shop floor and I can identify a particular job order. I cannot do that in process costing. Another key difference between a job shop and a flow shop is a job shop tends to be demand driven. In other words, we manufacture inventory for demand, as opposed to a flow shop, which tends to be highly automated and we basically operate 24/7. So when we're talking about cost measurement systems, they exist on a continuum with job shops at one extreme and flow shops, continuous flow shops at the other extreme. Then we have these intermediary steps. So if we look at the job shop there and we're contrasting standardization and customization of a product, the more standardized the product is, the more cost efficient it's going to be to manufacture. However, we sacrifice customization and vice versa. The more customized a product is, the harder it is to operate at high volumes, mass production, standardization, so forth and so on. So the most extreme case of a job shop would be one where we work with specific job orders, batches, the orders are somewhat similar, assembly line, mass customization, and then continuous flow. And as I mentioned before, a good example, or one I always utilize in class, of a continuous flow operation would be the manufacture of chemicals or paint or something like that. Now this little diagram here is very important and we'll make reference to it repeatedly, but it introduces the idea of actual costing versus budgeted costing or normal costing. Specifically, when we talk about actual costing versus normal costing, we're referring to our indirect manufacturing overhead costs. And notice that the difference between the two is that with actual costing, we're going to use an actual indirect rate, as opposed to with normal costing, where we're going to use a normalized or budgeted indirect rate. So when we get into the job order costing material here in Chapter 4, and we see how we calculate our indirect manufacturing overhead rates, we have two fundamental questions we have to ask every time. One is, are we using actual costing or are we using normal costing? Sometimes normal costing is referred to as using predetermined rates or budgeted rates, but it's all the same thing. I use the term normal costing. So we ask the question, are we using actual costing or are we using normal costing? What does that mean? That means when we calculate our predetermined manufacturing overhead rate, are we going to use actual numbers or are we going to use budget numbers? The second key question we have to ask is, what is my cost allocation base? In other words, that will be the denominator that we will use when we calculate our allocation rate, and we'll see that here in the next video when we look at job order costing. Finally, I want to make a point here. When we're talking about costing systems, a useful way to think about them is increasingly improving our costing system, making it more accurate, eliminating the noise in the system. If I had a super simple costing system, I just use one cost pool, I dump all my costs in it, and I allocate all of those costs to the cost object. That's as simple as it gets. My measurement costs, or my costs of operating that cost system, are going to be very low, but the potential errors in that system are going to be quite high because there's going to be a lot of noise and distortion in that system. Likewise, if I have a more refined costing system, and we'll see what I mean by refinement here when we start looking at Chapter 4, but as my costing system gets more refined, what happens? The cost of errors goes down because it does a better job of assigning cost to cost objects, but at the same time the system becomes more complex and it becomes more costly to operate. So something we always want to keep in mind is there's a sweet spot. There's an optimal degree of refinement where we balance those two different types of costs that we're working with, the cost of errors and the cost of measurement. In other words, if we have a costing system that is super refined, it may be too costly to operate. And that's just as problematic as having a costing system that's way too simplistic and it gives us information that is not very accurate and highly distorted. Okay, that's it for this video.